Hi everyone. In this video, we are going to prove another trigonometric identity involving three interior angles of a triangle. That means the condition is that the sum of the three angles would be 180 degree or pi radian. I have a few notes here on the screen. All of these conditions are true when a plus b plus c is equal to 180 degree. That means the sum of the three angles is equal to 180 degree or pi radian. So let's take a look at the trigonometric identity that we are going to prove in this video. The identity looks like this: sine squared of a plus sine squared of b plus sine squared of c is equal to 2 plus 2 times cosine of a times cosine of b times cosine of c. That's exactly what we have to prove. And for the proof, we are going to use a few basic trigonometric concepts. And the first concept that we are going to use is the Pythagorean identity that says that sine squared of theta plus cosine squared of theta is equal to 1. And from here, we can say that sine squared of theta can be written as 1 minus cosine squared of theta. And the second concept that we are going to use is cosine of 2 theta is equal to 1 minus 2 times sine squared of theta. From here, we can say that 2 times sine squared of theta can be written as 1 minus cosine of 2 theta. And the third concept that we are going to use is cosine of pi minus theta can be written as negative cosine of theta. So let's get started with the proof. And for the proof, we are going to start with the left hand side, which is actually sine squared of a plus sine squared of b plus sine squared of c. And we are going to transform them into other forms, and then eventually we will try to arrive at the desired right hand side form, which is 2 plus 2 times cosine of a times cosine of b times cosine of c. So from here, in the first step, what we can do? Let's multiply the first two terms by 2, and then also let's divide by 2. So this is how we are going to write it. So here I have written that 2 times sine squared of a plus 2 times sine squared of b. Essentially I have multiplied by 2. So now what I am going to do? I am going to divide this by 2. That means outside of the bracket I will say this is 1/2. So 1/2 times this quantity, which is essentially same as sine squared of a plus sine squared of b. And then outside of the bracket I am going to keep sine squared of c as is. And from here, what we are going to do, let's now convert 2 times sine squared of a into cosine of 2a form. So from here we can say then this is equal to 1/2 times 2 times sine squared of a can be written as 1 minus cosine of 2a plus 2 times sine squared of b can be written as 1 minus cosine of 2b. And outside of the bracket, of course, we have sine squared of c. And if we simplify this, this can be written as 1/2 times. Within the bracket, we have 1 plus 1, that is 2. And then minus, we can say this is the sum of cosine of 2a and cosine of 2b. And outside of the bracket, of course, we have sine squared of c. Now, we are going to convert cosine of 2a plus cosine of 2b into the product form. So we can write it as 1/2 times 2 minus cosine of 2a plus cosine of 2b. We can use the cosine of c plus cosine of d form, so that would be 2 times cosine of c plus d over 2 times cosine of c minus d over 2. So that would be 2 times cosine of 2a plus 2b over 2 times cosine of 2a minus 2b over 2. And then outside, of course, we have positive sine squared of c. Now inside the bracket, let's see what we have. So we have 1/2 times, that is outside, of course, and then inside the bracket we have 2 minus 2 times cosine of a plus b times cosine of a minus b, because 2a plus 2b over 2 is essentially a plus b, and similarly 2a minus 2b over 2 is also a minus b, and outside we have positive sine squared of c. And from here, let's convert a plus b into pi minus c. So in place of a plus b, we are going to write pi minus c. So that would be 1/2 times. Within the bracket, we have 2 minus 2 times cosine of, in place of a plus b, I am going to write pi minus c, because we know that the sum of a, b and c is equal to pi radian. So a plus b will be equal to pi minus c radian, and times cosine of a minus b, I am going to keep that as is, plus sine squared of c. And let's simplify further. So from here, what can we say? Well, this is equal to 1/2 times. Within the bracket, we have 2 minus 2 times cosine of negative cosine of c times cosine of a minus b plus this sine squared of c. Now what I'm going to do, I'm going to convert this into 1 minus cosine squared of c. Using the Pythagorean identity, I'm converting sine squared of c into 1 minus cosine squared of c. Now let's remove the bracket and see what happens. So from here, we can say, well, this will be 1/2 times 2, so that would be 1, minus 1/2 times 2, that is again 1, and minus cosine of c, that will become plus, so I am writing positive sign there, so that would be cosine of c times cosine of a minus b. Then outside we have plus 1 minus cosine squared of c, and from here we can see that we have a 1 and another plus 1, so that would be 2, and then we have plus cosine of c times cosine of a minus b minus cosine squared of c. And from here, if you look at the second and the third term, we have a nice common factor there. Cosine of c is the common factor, so I am going to write it as 2 plus cosine of c times, we will have cosine of a minus b and then minus cosine of c, and now I am going to convert the cosine of c into cosine of a plus b form. So let's see how that works out. So we can write it as 2 plus cosine of c times, inside the bracket we have cosine of a minus b minus cosine of, wherever we have the c, I am going to write it as pi minus a plus b. Think about it. The angle C can be written as pi minus the sum of the other two angles, because their sum is pi radian. So one of the angles can be represented as pi minus the sum of the other two. And now let's simplify this little bit. So this can be written as 2 plus cosine of C times cosine of a minus b, and this will become minus negative cosine of a plus b. And then in the next step, we can write this as 2 plus cosine of c times cosine of a minus b plus cosine of a plus b, and we know that cosine of a plus b plus cosine of a minus b, that is equal to 2 times cosine of a times cosine of b. So then we can write it as 2 plus cosine of c, and within the bracket it would be 2 times cosine of a times cosine of b. That's another trigonometric concept we are using here. Actually the concept is like this. You can say cosine of a plus b plus cosine of a minus b is equal to 2 times cosine of a times cosine of b. That's the formula I am using here. So from here, what can we say? Well, you can clearly see that this is nothing but 2 plus 2 times, if we remove the bracket, we can say 2 times cosine of a times cosine of b times cosine of c. And that's exactly what we needed to prove. This is in fact equal to the right hand side, and that's exactly what we wanted to prove. So our identity has been proved now. So we simply used a few basic trigonometric concepts to prove this identity. In the next video, I am going to prove another trigonometric identity. I hope everything made sense in this video. Thank you for watching. See you in the next video.